What's up, Accelerator Algebra 2 Stirrup here. So remember we skipped 6D. There is a worksheet on 6D which goes along with 6B. Should do the odds on that. But I am going to be using Desmos. On this one they want us to use a graphing calculator, so I'm going to use Desmos. I know we've talked about the graphing calculator in class. Desmos is another nice powerful function to graphing for you. So let's get started. We're going to talk about the X and Y intercepts using the graphing calculator. Find relative max and mins. Okay, we found the absolute maxes and mins when we were talking about end behavior. So now we're talking about like the turning points in the graph itself. Okay, so our very first one, if we were to graph the x minus 2 quantity squared x plus 1, so I'm going to go to Desmos and plug that in. So I go y equals x minus 2 quantity squared. And I forgot what the other part of it was. So we get down to our x minus 2 and x plus 1. Sorry about that. And then x plus 1. There's some things that definitely take place with this graph. So you might notice that, hey, it has a y-intercept of 0, 4, crosses there, actually bounces there, doesn't it? Wouldn't you say that's kind of a bounce? It's bouncing off it. So that's something that we're going to talk about in a little bit in detail. So we have -1, +2. Those are solutions to the problem. At the +2, we get a bounce. So that's something with our graph, and we're going to talk about that. And then 0, 4 happens to be a where it crosses the y-intercept. And in this case, it happens to be a max. Okay, I'm going to come back to this. Okay, so we have a local max at 0, at 0, 4. Okay, kind of came up here. But then at -1, I get the -1 from here, and the +2 I'm getting from here. Okay, so if we went back to that Desmos, we saw it did this. Okay, why did we bounce? The reason we bounced is because that was raised to the second power. We have a local minimum actually at that bounce. So at 2, 0 is a local minimum. And then they want to know, where is it increasing with our bounce? Okay, or for each of these. So right here, we're increasing coming up on that min. So from -infinity to 0, we are increasing, and then we're also increasing over here now. So we're also increasing from 2 to infinity. And notice I'm using the soft brackets because right at where the 0, 4 or the 2, 0 exist, it's not increasing or decreasing. It actually has a slope of 0. So increasing means my slope, m, which is slope, would be positive if I picked any 2 points. If I picked 2 points along there, I'd get a positive slope. Now we're going to take a look at when it's decreasing. Well, it's decreasing here. That's my decreasing region. So you're talking about using the x to talk about it. So it's from 0 to 2, it's decreasing. Okay, and if it's decreasing, that means my slope would have to be negative. So if I pick 2 points along that and use my slope equation, I mean, honestly, it's just the algebra 1 slope equation. So that's where we have it decreasing. So graphing y-intercepts, we have that. There's a y-intercept right there. Turning points, so turning point here and here. They happen to be our local max and min. And then we have increasing and decreasing on our graph. Okay, I think that we answered everything on this question, I think. Yep. All right, let's go to the next one. Again, we're going to go back to Desmos and talk about it. Okay. So things just by looking at this. Okay, so I got 1/4 x minus 2. So let me go back to Desmos. What was that? It was x minus 2? X minus 2, and then we had something bigger here. It was like x squared minus x plus 3. X squared. I just forgot what it was. I had that silly message that popped up. X squared minus x plus 3. Minus x plus 3. Okay, so here is our equation. So a few things to note. This is where it's crossing at the y intercept. And this is where it's crossing at our solution. So what do we know about this graph? So let's go ahead and plot those 2 points on for a graph. So 0, negative 1.5. So a point there. And if I go back at 2, 0. So what is this graph looking like? Oops, this wasn't there. It was supposed to be down here. Sorry about that. So this graph kind of has this look to this. It doesn't really change a huge direction at all. Do we have a local max and a local min? No, it doesn't. And how we're going to define that local min and local max, let's think about what this graph is doing. Let me just bring up the highlighter and see if that works for us. So this entire graph, when we look at it, it doesn't ever go down. The slope is changing, yes, but it's not changing to where it changes to a negative slope at all. So where is this graph increasing? Well, from negative to positive infinity, the entire graph is increasing. Okay? Decreasing does not exist on this graph because it doesn't ever start going back down. It approaches it, but it doesn't start going back down at all. Okay, we have the y-intercept right there. So the y-intercept is at 0, negative 1.5. Locate the exact locations of turning points. We don't have them. Okay, we do have some turns in it, but it doesn't like go from going up to going down. So that's what we'll have to look at. Kind of tricky on that one when you're looking at it. We could talk about that in class too. All right, using the calculator, let's find the x-intercepts. So I'm going to go back to Desmos. 2x to the third. So y equals 2x raised to the third plus 7x plus 2. Ooh. Did I have that in there right? I sure do. Okay, so looking at that, and I could zoom out. Like this graph isn't going to start coming back down. Okay, we do have where it crosses the x-axis. We can zoom in on that point. Negative 0.3 roughly. And we have where it crosses the y-axis up here, 0, 2. But this graph doesn't have any changing directions on it. Okay, it's just going to go from negative infinity to positive infinity, be increasing the entire way. So x-intercepts, gosh, what did we say it was? It was right here. Roughly negative 0.3. Yikes. So negative 0.3, comma 0. Local max, none. Local mins, none, because remember our graph kind of like did this. Okay, it's increasing the entire graph. So from negative and positive infinity, does this graph have any decreasing? No. Meaning if I picked any 2 points along that graph and I found the slope using the slope equation, y2 minus y1 over x2 minus x1, it would be a positive slope. Okay, so this means that we would have a slope positive no matter what 2 points. If I picked a point here and I picked a point here or wherever, my slope will be positive. Okay, so that's increasing. Okay, now we have a picture to look at. Suppose you've been asked to take a 5x7 sheet of paper and make it into a box without a top that holds pretzels. The graph below shows how the volume changes as the height is increased. At what side is the volume maximized? Right here. So if I have a 1-inch side, I have a volume of 15 cubic inches. What is the maximum volume that pretzels will be held? 15 cubic inches. Okay, if you only wanted to have a volume of 12, so if I had sides of 0.5 or 1.5, my volume would be 12. And again, we can talk about more of this in class, and we can represent kind of what it looks like. Now we're going to start changing up the equations. Okay, so we have this soda can. So I want to solve this equation for H. Okay, I'm going to solve it for H. So I know that I have S minus 2 pi r squared equals 2 pi r h. And then if I divide both sides by 2 pi r, so my h is going to be 2 or S minus 2 pi r squared all over 2 pi r. Wow. The volume for the cylinder of this can is going to be that. So that means, oh my gosh, so I can plug that whole thing in. So I'm going to just show you what this might be one we might want to look at in class. So I have pi r squared, and I'm subbing in for h, my S minus 2 pi r squared over 2 pi r. So that's what my volume would be. Okay, this is definitely one that I want to look at more in class, okay? Because we're going to be using the TI graphing calculator on this one. So make sure you ask me in class to go over this problem. That way we can make sure we're good. If there's any problems on the homework like it, maybe start it, but I'm not going to expect you to have it done, okay? So take a look at 6D and do the odds. Don't forget the 6C odds as well, okay? There wasn't a no lecture for this because it went off of the B. Okay? That's all I have for you, my friends. Have a great day. Take care of one another. Bye-bye.